Yeah, let's wait for like 1 minute to let people gathering here.
Hi, Eddie.
Hey, Adam.
Hey.
Maybe let's wait for 1 more minute. Yeah, then we can start.
Hey, sorry, if I can interrupt. So, Kentaro, are you there?
Yes.
Hey, sorry, I'm trying to remember. So, are you the one that presented the NetCon today?
Yes.
I mean, sorry, Tuesday.
Yes.
Okay, great. So I just want to let you know that there's a working group created for UMF. I'm not sure if the person sent you the invite. Have you got the invite yet?
I'm not sure. I don't think so.
Okay, if not, is it okay if you actually share me your email address so I can pass it on?
Yes.
Yeah, thank you.
Good. Okay, we are 3 minutes past, so I think we can start it. So we start with the Kentaro. We talked about the next hop group for 2 weeks, and I think in like this week I want like to changing the topic to more talking about the BGP loading time. Hassan did that in the earlier at the beginning of this working group weekly meeting. Then this summer, like one of the intern is making some changes in our code base, so just do some experiment to see that where the bottleneck and how fast we can get. So he get some good results. So that's why I want him to present it and see that how we can moving forward for this to see moving to the master. So come up with the HOD. That's why I want him to present it today, and then we can discuss it after his presentation. Yeah. Anything else before we started?
Just wondering, we reached any conclusion on the zebra crash that Nokia had, Sakti actually had. I think you were following up, right?
Yes, I think that after he applied the diff, which removing the duplicate routes, then that crash go away. So they'll definitely come with the duplicated routes. But I still don't understand how he can get it. Because from the T2, that he only have one interface going toward the different line cards. So one suspect I have is basically because he get all these routes as a kernel routes. That looks very suspicious, which means they using some kind of inserting those routes to the kernel directly. So maybe like use static route like in Linux to do that. So then in that case, I was questioning him to see that is there any chance that his BGP learned routes will be coming first before he get the insertion first, because he has a default route which is going out. So there are two parts. The one is he has like the BGP route is 26 passes. Then normally, like if they only go over the remote line card, the only time one, so should not be expanding. The only thing I can think is like, so he didn't insert in the default route, but he has a /0 pointing to the other side for the same line card. So I suspect they are resolving through those routes. So they have the timing window there. That's my suspicion.
Yeah, I think you're right. When the interface goes down, these routes, which are supposed to be resolved via only one path, I think they are getting resolved recursively and multiple paths are being installed. Yeah.
But
yeah, I mean,
Yes, so but this is just my suspect, but I haven't got anything coming back saying which kind of script creating it was. So that's just so I don't know. So no case I didn't found my email, the last email yet.
Yeah, and we don't see anybody from that team here, right? So neither Sakti nor Arvind are present here, so we can continue with your agenda.
Yeah, but that's interesting. So that's why I want to later on, maybe like let's discuss this. Like, should we introduce? My goal is like I want to introducing the BGP picks in the FR eventually. So if we have BGP picks, then that will solve the problem for convergence, and also naturally will be solving this kind of recursive, because this kind of recursive should not clapping.
Yeah, I agree.
Yeah, so that's why I want to like say I'm looking for basically some Cisco guys to give us some say the introduction on the BGP picks, those things. So I pinged like Ahmed, who I worked with him before. He's the owner for that draft. So I have his response. If not, I'll probably wait for the Michael, who is on PTO right now. He will be back on 14th. Maybe I will let him to give us some discussion on start on the BGP picks point of view. Yeah. So for today, I will let a function to sharing his screen and show what he did in the summer and what's a change, because the result is very good. It's 16K routes per second. So I'm pretty happy on that. Although I set the initial goal is 20K, but the 16K I can take it.
Awesome.
Yeah. So Fuzhen, you want to share in your screen and start your
Okay, so
sorry, before you begin, 16K from where to where?
16K from the end-to-end process in an end-to-end process.
So were you actually sending traffic to all the destinations you've been downloading?
Yeah.
So so you stopped dropping traffic. Let's say if you would have been sending 16K routes, it would have taken exactly 1 second to stop dropping traffic.
Yeah.
And underlying hardware was what?
That's a Silicon One.
Okay, this stuff's pretty fast. Thanks.
But I think Broadcom also will be fast. I think like Hassan, correct me wrong. I think the SDK can get a 30K, right?
Yeah, I mean, SDK/SCI are much higher than actually the speed we are getting with the Orc agent.
Yeah, the reason we put on the Silicon One is because like that's the only platform currently we more focusing on the scale, because we are putting at the routers. So that's why we using Silicon One for testing. Thank you. Yeah. Okay, fun. Continue. Yeah.
Okay. So today I'm going to talk about my project, which is improve Orc agents routes downloading speed. And let's first look at the background. So we have tested the SONiC routes downloading speed by delivering 500,000 routes. And as shown in the left graph, it takes nearly 50 seconds and with the rate of only 10K routes per second. Also, we have a very powerful machine as shown in the right. It's the CPU model. It actually hasn't reached the bounds of our machine. So there might be some software bottleneck. So we analyzed the workflow of SONiC. The right graph shows the workflow of Orc agent. After Orc agent received published message.
Want to change to the presentation mode, so make it the front a little bit bigger.
Oh, okay.
Yeah. Thanks.
Better this time.
Yeah, thanks.
And yeah, back to Orc agent. So this graph shows the Orc agent workflow. So after Orc agent receive published message from APPLDB, it will do the following jobs. First, function pops will read data from APPLDB. And then function add to sync will record the routes in a local file. And finally, the function do task will push routes to ASIC-DB. All of these three functions are running in serial, as you can see in the graph. And we have measured their running time to process 20K routes from the log here. So you can see POPs takes like 0.55 second, and add to sync takes 0.3 second, and do task takes 1 second. So in total, work agent takes like 1.85 second to process 20K routes, and speed is around 10.8K routes per second. And the same situation happens in SYNC-D. They're running in serial. So this seems to be the bottleneck in SONiC for now. Then, in order to remove the bottleneck, we come up with an approach to use pipeline to download routes. So the right graph shows how pipeline works in org agent. From the time we measured before, we know that do task takes 1 second, and the POPs and add to sync together takes around 0.85 second. So we put POPs and add to sync together, which is the same time as do task. So we put the task here in thread B. So from this graph, you can see why pipeline can theoretically double the routing performance. And with the pipeline, we aim to improve route downloading speed from 10K per second to 20K per second.
So essentially, you have separated out the IO bound job, which is the radius POP, and there is another processing thread, which is actually which may be the main thread, and the IO thread is the one which is doing the POP. So basically, we have made it multi-threading. Is that correct?
I didn't quite get your question.
Yes, I think that's correct. One thread is for IO to POPs, and another is for do task. You are correct.
Okay. Sure. Okay.
And this is how we actually implement the pipeline. As you can see, there might be some difference from the design before, since we put add to sync and do task together. And I will explain that later. And also there are some changes in FPM SYNC-D, which is not mentioned before, and I will explain that later too. So in org agent, we implement a new consumer class. So it can POPs in thread A, which is the main thread before, and add to sync, do task together in a thread B, which is the thread we added. And in SYNC-D, we implement a new process bug event function. And also the same, it pops in thread A, which is the main thread, and deserialize and create route in the thread B, which is the thread we added. Also, we use ring buffer instead of mutex buffer to deliver route information between the threads. So there's no lock issue, and actually ring buffer works much faster than mutex buffer. And after we implemented the two pipeline or agent and SYNC-D, we test its performance. It actually became even worse. So we tried to find out what happened. So the log here on the left shows how org agent works. You can see the batch size here is around 128, which is not the same as before. Before we set the batch size to 20K, so it can pops 20K one time. And the right log shows how SYNC-D works. You can see the number here is small too, the size. And actually, Psi works poorly on this small pieces of data, which leads to the worst performance. So the reason is that FPM SYNC-D flush too often, and org agent has worked much faster than before. So for FPM SYNC-D, it actually flush every time after it received a net link message. And when org agent worked slower before, in the original SONiC. Routes can be buffered in Redis in APPLDB, but now Org agent works much faster. So it can only pop small piece of data. And this also costs too many Redis IO operations. So we add a flash timer in FMSync which flash Redis pipeline every 0.5 second to replace the original flash instructions for flushing routes in a large batch size.
I think,
Yeah.
Sorry for the interruption. Actually, I think that the flush timer will certainly add the delay and may cause the convergence issues as well. One optimization that you could have done is actually increase the buffer size between Zebra and FPM. Right now it's just 8K. I think it can be further increased. But 0.5 second, like 500 millisecond, is if there's no change in the network and one route flaps, for example, it'll take half a second for that route to go into the hardware. That will be the drawback.
Well, actually, like the pipeline has its own logic to flush, Redis pipeline to flush itself when the pipeline is full. So we can set pipeline size to like 10K, and it may not take like half a second to flush since the pipeline is full and it will flush itself. This flush timer is to make sure that all routes inside the Redis pipeline can be flushed rather than staying there, since we have removed all the flush instructions.
I think he was asking about the opposite case where you send one route down and you wait a half second for it to actually be installed.
Yeah. That's true. Yeah, I think the Hassan suggestion is valid. So because we don't want to like wait for a half second, because that will causing like a one route conversion issues.
Yeah. So this half second is just for testing. This is just a not the final version of our implementation.
Because Hassan suggested like say increasing the Zebra and the FPM like a buffer to basically sending more. I think right now it's a 4K, right, or 8K.
8K, and it can be increased, to any size,
any size here, right?
Yeah. This might be also a good solution. So here we test the route downloading speed SONiC with our modification. So as shown in the right here, it delivers 500,000 routes in 30 seconds with the downloading speed of 16K routes per second, compared to the original one here, which is 10.5K routes per second. It can improve routes downloading speed for more than 50%. And we also test Org agent to see how pipeline works. For Org agent, it can handle 26K routes per second now. And we actually implement the pipeline as how we design. In the first place, here you can see we put add to sync and pops together in the main thread and do task in another thread. But actually, in this case, do task works faster than before. Like it will take 1 second before, but now it only takes 0.6 seconds. So, and actually pops is slower. It takes 0.65 seconds. So we made some changes. We put add to sync and do task together and remove the mutex buffer and use rim buffer here. And also do task is faster, 10% faster with the rim buffer. And the total time only need like 0.75 seconds, and with the speed is 26K. So as you can see now, Org agent is no longer the bottleneck, and it actually can process much faster, like 26K routes per second than the SONiC performance in the end-to-end process, which is 16K. So there's a new bottleneck. Wait, sorry. Like,
I have a question here. Sorry for that actually. What is that the pop thread doing? So I know that it is actually popping from the Redis, But
Yeah.
is it also pushing into the M2 sync, or that job is being done in the main thread?
The M2 sync is pushed by M2 sync. Like firstly we use mutex to protect M2 sync, because M2 sync is written by both M2 sync and do task. So we need a mutex buffer there. So when we use ring buffer, we don't need that. Yeah.
Sure. So this ring buffer is the one that has to be protected. So the POP thread writes into it, and the main thread dequeues from it. So the buffer that POP thread has already worked on, that can be consumed by the main thread in parallel, while the POP thread is actually working on another buffer. This is what I think is happening here. Okay, got it.
Yeah. So we try to find. So we test all the module individually to find what's the new bottleneck. And it seems that Zebra is the new bottleneck. Like from the log on the right, you can see that Zebra takes 29 seconds to send 500K routes to FPM sync D. And the speed is around 17K. So this might be the new bottleneck.
Yeah, I think we talked about it before. I was also under the same impression that Zebra is the bottleneck, because in my measurements, I was comparing the time Zebra takes to install a million route in the hardware versus how much time it takes to send it to FPM sync D. And FPM sync D was way slower. And so the exercise that I did was I started dropping the messages in FPM sync D immediately after I received from the socket buffer. And I reran the test, and what I could see is that Zebra was able to send the same amount of route to FPM sync D within the same time, actually, that it was taking for the kernel. So essentially, the reason why Zebra is showing this bottleneck is because there's a back pressure from the FPM sync D. So Zebra is not able to push more routes. And FPM sync D might be busy doing a flush. So either if you increase the buffer size or we improve the flush performance, I think Zebra might still be showing that it's not able to push these many routes.
You mean the FPMD is flushing to Redis, so Zebra can't send routes to FPM sync D. But actually, I've changed FPM sync D with the flush timer. It actually flushed the pipeline in another thread, so it's actually not the same. Maybe not the same here, I think.
So yeah, so either the processing of the route or the flush, I think. So the first thing that you can do is increase the buffer size, and you will certainly see Zebra taking less amount of time.
Yeah. Maybe I'll try that.
Yeah.
But so here this shows that Zebra actually take like 99% of CPU utilization, while FPM sync D and other parts is not. So like from this, I think that Zebra might be the bottleneck. Yeah, maybe
Hey, let's take a step back. It doesn't quite work that way. Zebra is multi-threaded itself. So that number of CPU percentage is meaningless. So you can't make that conclusion from that statement, from those facts. Okay. And the second thing I like to point out is that I would, if you're concerned about Zebra being able to push down fast enough, I would convert Zebra FPM to use netlink batching like the Linux kernel receives. You could probably save a bunch on read writes cycles by just having Zebra shove more data down at one time in one write cycle, if you're really interested in it. But I would be hesitant to say anything about Zebra's taking CPU percentage based on the fact it's got P threads. That's a meaningless thing from my perspective.
Yeah, I agree. I agree with Donald, actually. I think I was able to achieve 30-second route for 1 million. 30-second for 1 million routes to be sent to kernel as well as to FPM SINC. I think 30-second is a good number.
I actually think you can make it smaller too, because like sending 1 million routes on my machine is like 6 or 7 seconds. So you got another 17 seconds of delay that the FPM SINC is adding in there. So there might be things you can do with Zebra to speed up, but I'd be cautious about saying Zebra. I'd want more data before I come to this conclusion.
So you're saying 6 to 7 seconds on your machine, but then maybe we're not comparing apple to apple, right? These are like the platforms which are like 2.5 gigahertz of CPU, and the way I was.
Okay, I said that poorly. So when I run 1 million route installs on my home machine, 6-7 seconds. When I turn on FPM SINC, I mean, I turn on FPM and I have like a little daemon that just reads the route and drops it on the floor, right? And it more than doubles the time.
Yeah, but then which machine is it? Is it a server or it's a router?
It's a machine with a CPU, and that's all that matters. And I'm just
I
saying
agree.
that,
so this is what
what I was saying was that the fact that we're using both the data plane and the FPM more than doubles the time that just using installing the routes into the Linux kernel, which implies to me that things like the read-write, the write cycle of batching more netlink messages at one time would be advantageous. I also think we could probably do some things in Zebra to increase the pipeline there a bit as well. But that's like high end, like have the data plane break up into multiple P threads and shove the data to Linux kernel, then hand the data to the next one and have the Linux kernel working on the next, make 2 P threads, one for the data plane to the kernel and one for the installation routes on the FPM. And you might actually see a pretty good improvement in speed up there. But I don't know. We're just, spitballing here now.
Well, I think the bottom line, we know the Zebra can push about 150K routes a second. And before SONiC reaches this number, probably should keep looking into FPM optimization and work you've been doing actually as well.
Yeah, and I think I know we know that Eddie's working on a thing to not install the route based on a route map, right? And that'd be a great thing to test here, in all honesty.
Sure. Actually, we can add that one, basically. Yeah. But the Zebra sending to the kernel in another thread, right? Ideally, they should not impact, right? Even I skip or not skipping, right?
So to clarify what I was saying, currently the data plane P thread in Zebra receives a bunch of context data plane routes to install at one time and hands it to the Linux kernel to install, and then lets the kernel install all X number of those contexts, those routes. And then it hands it to the FPM.
Okay.
And all I'm saying is if you subdivide that, the handling around of data plane context so you pass it to the Linux kernel first, and then those group of contexts get transferred to the next P thread in the chain, while that first P thread can go back and start handling the next bit of data. And I think there could be work done there that would speed things up, but and probably long term that's where we should go, but I'm not sure that that's going to be better long term than just not installing the routes in the Linux kernel, if that's really important to everyone. But I'm not sure it's actually important either for everyone.
You probably can take a look on that. Yes.
I agree that if you have a separate pthread for every data plane, it might be the best.
But do we
It'll
need to
speak-
have a sync, right? We need to sync on this sometimes.
Say
I
that
think
again,
for-
Andy?
No, I would say like, do we need to like say for the SRv6? Probably I don't want to install the kernel may not be a big deal, but if for the general like say normal routing, we want the slow path and the fast path in sync, right?
Sure.
Yeah, that's good. Yeah.
And I should continue.
Yeah, go ahead.
And also, we find out that vendor side lab might need to have some performance tuning. So in an end-to-end process, for SYNC could finish 500K prefixes insertion in 30 seconds, which is about 16K routes per second. But during the stress test, SYNC insertion rate is not consistent. It has a quick start but slow down in the middle of processing. And you can see here, like in the beginning, it takes like around half a second to process 10K routes. But in the middle, it will take more than 1 second, like 1.2 seconds to process 10K. And at last here, it became faster, like from 1 second to less than 0.4 seconds. So this might be a problem too.
This could be platform specific as well, right?
Yeah.
Because it is making the cycles, and it all depends on what cycles are doing internally.
Yeah.
Yeah, this data I will send to my Cisco friends.
Yeah.
So finally, with our approach of software pipeline, we improve Org agent for 150%, like from 10.5K per second to 26K routes per second. In end-to-end process, it improves 50%, like from 10.5K to 16K. And this table shows the speed of each model. Like from the original, you can see that Org agent is the bottleneck. Its speed is slow. And from here, the end-to-end process is actually same. And I doubt that Zebra or SYNC may be the bottleneck. So, and actually we have tested Zebra separately too. Like its speed is to like 25K and the same as FTM SYNC. So actually, I don't think FTM SYNC is the reason why Zebra is making to 17 here. So I doubt that. Then maybe some CPU scheduling problem or separate Zebra in a core apart from all this other process, and maybe that will make it better. And also for SYNC, this number cannot represent its actual speed. It's only its top speed, like for 10K for less than 0.4 seconds. So it works inconsistently. Yeah. And that's all. Thank you.
Can you go back to your previous slide?
Yeah, here.
So this is the interesting part. I also can understand. The only thing I can think is like the SYNC may be various, so inconsistent. So that's why the 25K may. Otherwise, ideally, since everybody is fast, we should be even getting something more than that. So I don't know if you other guys have any opinion on that. So the only thing I can say for the SYNC probably.
Actually,
Yeah.
so sorry for the interruption. Actually, I don't understand the difference between end-to-end pipeline and the module test pipeline?
Like, so for the module test, we actually like, we only run Zebra, or only run FPMCD, or we only run Orc agent, like separately, not in a whole process. From the end to end, it means that the roads come from BGP to Zebra to FPMCD and finally to SYNCD.
So when you say FPM SYNCD module test, so you're sending the route from Zebra and then FPM SYNCD is dropping it?
FPMCD writes the roads to Redis.
Okay, so you're saying that this is the it's still the end-to-end test, but we are looking at the performance at each point.
Like, yeah, so I test FPMCD like from Redis to see how many roads it's pushed to the APPL DB to, yeah.
So how do you do the pushing? Like I say, how do you insert the routes to the FPMCD? Through the Zebra or you through some test routine?
Through Zebra. So these two numbers same, since Zebra send 25K to FPMCD, and FPMCD can handle them all the same.
But you don't have the bottom part, like I say, the Orc agent, those running only is.
Yeah.
Okay, so it is FPM SYNCD is actually writing in the AppDB, but there's nobody who is consuming that from the other side.
Yeah.
Okay, and when we say Orc agent, it is receiving from the AppDB, but it is not writing to the SYNCD.
It writes to SYNCD, but nobody is consuming from SYNCD.
Okay, it writes to the ASIC DB, but nobody consuming from the ASIC DB.
Yeah.
But then why should it actually be higher in that case if SYNCD is not there? Because from Orc agent point of view, the only job anyway it is doing is just writing into the AppDB, I mean the ASIC DB, whether SYNCD is really consuming it or not.
You mean from 16K to 26K?
Yeah,
like
yeah.
Performance higher. So in the end-to-end process, it's like Zebra or FPMCD is slower. Like it can only provide 17K routes per second. So the Orc agent cannot work at this speed. So this speed is not its top speed, it's the actual speed in the end-to-end process.
So how could you push the routes? I mean, did you already have the route in the AppDB when you started Orc agent?
Yeah. I just delete all the publish commands in the APPL DB, so the data are there, but Orc agent hasn't been consumed before I started it.
Okay. Sure.
So I wonder how representative this test is. Let's say if you gated by Zebra download speed, the rest is going to be just not faster than it's the weakest link. Or actually anyone in the chain who is weakest link will kind of influence the end result, right? Because you're not really testing every model separately. You're using the top model to push routes. So I think it would be really good if you can completely disaggregate the testing.
I think the Orc agent testing that does that, right? He basically to let all the routes sit in the AppDB first, then only testing the Orc agent.
Yeah, like for Orc agent and SYNCD, I just buffer the routes in the Redis and it's tested separately.
Okay.
So this is really, like I say, the module level. So you see, that's why it's interesting to see that on each module, it looks like we can get to 26K routes per second. But right now, the end-to-end is only the A16K. So somewhere somebody is not reaching the 25K. Basically.
Yeah, so I think, maybe I take back anyway. I just want to bring up one point that if you increase the buffer size between Zebra and FPM SYNCD, the 50% improvement, you can easily get it to like 70%, I would say. because when I did this testing, and I increased the buffer size from 8K to 1 MB, I could easily see 20% improvement in the route download time end to end. So yeah, try it out.
Yeah.
Hassan, what would be the drawback? Why wouldn't we just do it then?
Why wouldn't we do what?
Why wouldn't we increase buffer size permanently?
Yeah, we can. We can. This is what I'm proposing.
Are there any drawbacks you've observed?
I don't see any drawback. I think 1 MB, even if it's all gone from the system, it should still be it should not be a problem. There is enough memory on these platforms.
Cool.
Hi, so I have a question. So for the end-to-end pipeline module test pipeline, why is performance of Zebra different?
Like I mentioned before, it might be some CPU scheduling issue, like there are too many threads running, and they might take CPU away from Zebra. And I will try to separate Zebra from other threads to see if it can work better.
So how did you push route to Zebra?
Like through BGP.
BGP for both cases. Interesting.
Yeah, this is the BGP loading time. So pretty much we only do the BGP. This is the measurement for the BGP loading.
So it should be same, right? But different from some unknown reason.
Yeah.
Okay, thank you.
So Eddie, I think I interrupted you. You were talking about SINCD, which I was not able to comprehend. That's why I asked this question. Maybe you want to repeat?
No, my say like I always suspected the 25K may not be the valid, or because the SINCD is not consistent from the previous slide. So if the SINCD going down, then maybe back pressure. That's why we going only see the 16K end to end. That's my suspicious part, I would say. Yeah. But you mentioned like you get 20K routes per second, right? Hassan?
Quickly check. Actually, what I was able to achieve was 200. Yeah, it was slow actually. Just like, yeah, which is much slower than actually what you have achieved. And I think the bottleneck was the ARC agent IO and the CPU bound processing happening one after another. Just one point though here that you are using the buffer, what do you call the bulking between the ARC agent and the SINCD, right?
What do you mean?
So, so this is actually using the bulking, and it is working in the synchronous mode. This is synchronous side, right? Not the asynchronous side.
And can you comment on? I think we using the asynchronous, right?
Yes, actually in our SONiC version, we test okay. Yeah, we use the latest SONiC. It's asynchronous mode.
Is asynchronous mode or synchronous mode? Sorry about that.
Async.
Async mode, okay. Okay, so that may be the reason. That may be one of the reasons why actually you're seeing better performance. So if it is asynchronous mode, we are not waiting for the response back from the SIMD. So ideally, ARC agent should not be blocked, even if SIMD is slower.
Yes, and in the sync mode, we observed that the performance is much slower.
Correct. Yeah, because we send one bulk buffer and then wait for the response and then send the next one.
Yes.
So that may answer your concern, Eddie, that it may not help. Maybe SIMD is not the problem actually.
Okay. Then that'll be very interesting. What else we can?
Yeah.
Because it doesn't match up to see why we cannot reach 26 or 25, right?
Yeah, and I think as Jeff was saying, the bottleneck is actually somewhere in the beginning of the pipeline rather than towards the end of the pipeline.
Oh, you mean in the FR side? But well, I thought like if you see that Donna just sent out he get like 1 million for 7 seconds, right? That's super fast. So I doubt it should be FR because from my experience previously, normally like BGP, because it's just a software, so it doesn't sound like fast. It should be fast.
Yeah, I mean, yeah, I agree. But then I think we do need the cat proc CPU info as well to compare. 7 second, yeah. I mean, if the CPU is pretty fast, yes, it is very much possible.
Yeah, that's something that sounds very interesting. So why we didn't reach in? We still have like almost 10K routes per second gap in between.
I mean, think about it. You've got 1, 2, 3, 4 different processes that you're passing data in. And just the sheer fact that Zebra is going to pass data to FPM Sync D, then FPM Sync D has to wake up, process it, then pass it to Orc Agent, then pass it to Sync D. I mean, that's just, I think if we're really concerned about really speeding up the architecture, well, then figure out how to get rid of one of those demons.
But we have a lot of cores, right? Okay, but can you go back to your first one to showing the CPU?
So
ideally, so yeah, I agree with you. Sometimes I could be scheduled to the different. I have like a 12 CPUs here, and each of 2 threads. So in logically I can have 26, 24 like running in parallel. So
yeah, but I'm not. The number of cores I have says absolutely nothing about how fast I can move data between processes that may or may not be running on the same core.
Okay, I see. Okay, I see. So you're saying like moving the data across in the process itself may eventually become the bottleneck.
Oh yeah, I can almost guarantee you that's the bottleneck. We got 4 different processes that have to wake up and do stuff. Get rid of one of them or 2 of them. And I bet you'll see some significant improvements.
I don't want that. The only thing I think I want to get rid of, or the only thing I probably the FPM Sync D. Other than that, I don't want to get rid of it. But get rid of any of the process is a big surgery. Yeah.
Well, I think that's how you're going to get real high-end performance.
I probably stay with this one for now. Yeah, because this is a 16K. I'm thinking that at least for me, I feel it's comfortable to stay for a while. Yeah. So I don't know, like Hassan or say anyone say for the F. Some I know like Microsoft guide explode say 0MQ. For the communication, I don't know if the one could be used or anyone exploring like to say from awk agent to the SYNC-D using the 0MQ, those kind of a communication instead of using the radius.
Eddie, I think you need to reduce number of layers, not to increase, right? So yeah, if you look at kind of high-end stuff, usually routes will be published into shared memory and then consumed by asynchronization daemon immediately without all the stuff in between. But this would be real surgery for, I mean, heart surgery for SONiC.
That's the very big surgery. Yeah. I agree with you. If I was design initially, I probably don't do the radius. I was using the M-try or those kind of the tree structures to sharing those data. But since we already started, so it's a big surgery. This is more like architecture level changing. So this is, I would say, until I get like say, I probably like the until I get like 20K routes per second, I probably won't even think about it.
But Donald is absolutely right? You could dance around with more threads here and there, but practically, since you've got many processes acting on the same data, this is a bottleneck architecturally.
So you mean like say even like adding improve the efficiency on the communication or anything like say maybe I still around the 16K because the data move itself eventually become the bottleneck.
Yeah, which is tactical optimization, right? You might get few more Ks here and there.
Yeah. Okay.
I mean, one thing that immediately comes, like you mentioned it, get rid of FPM SYNC-D and have like the org agent be the FPM SYNC-D.
Yeah.
All right, but I still don't think that's, I mean, if you want performance, it's still not going to solve the problem.
That's true, because here we didn't really count the radius. The data itself is separate process. So here he only showing like say like a full process Zebra, FPM SYNC-D, awk agent, and SYNC-D. So, but in the between, we also have a couple of the radius, and also we have BGP there. So there are quite a lot of processes sitting there. Yeah. Okay. Yeah.
Yeah, I mean, it goes against the architecture to remove any of these layers,
Yeah.
especially DB.
I would stay with where we are for now until I get to the 20K. Then if I see the more requirements, if I need to get to more routes over the 2 million, then we can come back to discuss. Or if somebody have like a more requirement, we can discuss that. Yeah. So for now, I will see that I like these numbers. So I was thinking that we like say come up with some kind of, if ever feel comfortable with this approach, I would rather just raise the last time to change this one to the HLD, then we get consensus for this approach. So I want to see. Yeah.
Or Young directly, could you please retest number one with larger buffer? So let's say 1 meg or more. Number two against other hardware to see if by chance you are not hitting Silicon One SDK limitations.
Okay, so you one is the large buffer, I can do it. The other one, 1 million routes on the Broadcom chip, I need to see that which platform we can try. Yeah.
Yes. So I'm sorry, I know there are Broadcom people on call.
Yeah, so TD4, X9 or X11 based platform, any of the platform. There are a few from Dell.
Yeah.
So what would be the SDK limitation? I assume it would be somewhere below 20K, right?
No, so we support 1 million, on these platforms on TD4.
No, I'm not talking about number of routes. I'm talking about the download speed.
Yeah, so we have the benchmarks from the SAI/SDK, and it was much higher, I think. If I don't remember exactly, but it was above 30K, even more than that. I don't remember.
I think the number I got from you guys is 30K. Yeah.
Yeah. Yeah.
Okay, so in other words, we can use this hardware for this. You don't need something like Jericho really to remove a bottleneck. Cool. So I think, yeah, if you could retest it with these changes, then it would be clear whether this change should be going in the way it is.
Meaning, what's your concern?
No concerns. We want to understand whether there are some additional bottlenecks that could be solved. And so your change, for example, will include buffer increase, right? We don't want to do this separately.
Okay, I see what you mean. Yeah. Yeah, yeah, sure, we can do that. I need to check with the team to see that if we have like say the TD4 which can support 1 million routes. Yeah, because our platform normally we don't have that 1 million routes on the TD4, so I don't want to stretch too much in those kind of platforms. But let me check.
Thanks.
Yeah.
There's another food for thought is there's a Lua script that runs when you do the pop from Redis. And if you see, it does the pop in pretty slow fashion, in the sense like it scans, it gets the list of these tables and then prepares the list. And then it starts converting each of these route entries, which are originally will be with underscore in the beginning. And it starts replacing them with without the underscore. That is the way actually how the producer consumer thing work, because the producer writes with underscore. When it is consumed, the underscore goes away. And that is actually going to put a lot of stress. I would be interested in actually comparing and basically replacing that app DB with the state DB, because that is what the actual Redis is, that you push in from one side and you pop from the other side. I think that exercise can identify whether Redis itself is a bottleneck or the way we are using Redis is the bottleneck.
So you are suggesting, like I say, using the state DB because it doesn't have the raw script. So
Correct.
So then we using that temporary as a channel to pass in, right?
Correct. Because if you run these Redis benchmark tests on these platforms, you can easily see like 30K or more than that actually per second. So Redis natively is able to process at a lot higher speed.
Gotcha. Okay. Good. That's good comments. So right now I see that there's 3 requests or the AI actions. So one is increasing the buffer, one is using the Broadcom TD4 to do the testing, one is the, like I say, basically testing the Lua script performance, basically replacing the app DB and with the state DB to give a try, right?
Yeah.
Then we see that what else? So what is the performance number we could see? Yeah, that's a good one. Yeah. Then from there we can see that what is the standpoint, see how we can finalizing it. Yeah.
Yeah, I mean, it's like peeling the onion. I mean, you resolve one bottleneck, you get to see the other one, and then you resolve another one. It goes on.
That's a fair point. But the problem is like as a peeling onion, right? It will never end.
Yeah, I agree.
Yeah.
I think it will end at 30K per second.
I probably won't be at that. I was like 20 is good for me.
Yeah.
So 20K per second as compared to 200 per second 4 years ago, it's really good progress.
Yeah.
I think it was never 200 routes per second. It was I think the worst was 5,000 routes per second, if I remember.
I think generally right now it's around 5K, right? Because I think that's another email that I think it's one of my friend colleague asking, like someone reducing the buffer size, right? But no, batch size. Yeah, we put it in the community like a email list. I don't know if anybody read that one or have any comments on that.
I did not pay attention.
Let me see. There's the bulk size for the. So let me share. Yeah, just. So this is the email which we say there's the pull request for this one. So let me open this guy. So this is basically the limited size of that. So let me do the change.
This is a bulker.
Yeah, bulker, yeah. Because this one basically reducing the bulker size. I found where it is reducing it. So I just anyone have the context why we do that.
It might negatively impact the performance, right? If you're reducing.
Yeah, it's a negative impact, yes. So this something like looks like the Microsoft guy added, right?
Well, it could be on their platform. It improves their performance. We don't know. They have given insufficient data.
Yeah. Okay, I'll probably Rita is not in probably like after I'll ask Rita to see this. Yeah, because this is something we saw it in after we merged into 2205. Then we found, hey, this is the bottleneck. So we try to understand why we put this. Yeah. So right now we removed that, but it will be good to understand what's the motivation behind it.
Yeah, I think, as the description says, the limitation is coming from the SI. The SI is timing out.
Mm-hmm. But then in that case, should we fixing the style or those things? I don't know. Yeah. So this is something looks interesting. Yeah.
Yeah, if the SI is faster, then the timeout in the occasion should not happen. This is what I understand. Yeah. Yeah.
Anyway, so this is something probably I would probably let me once the Richard come back, I will ask him to see that if he can get some detailed information on that. Okay. Good. Anything else?
Thank you. Thank you so much. It was very good information.
Yeah. Good. So hopefully we can get some good numbers eventually on the SONiC side. Yeah. Good.
Eddie, thanks so much for doing the work. Really good. So
yeah. And consider this is the intern's work.
Awesome.
Yeah. Good. Thanks. Mm-hmm.
Thank you. Thanks, everyone.
bye.
Bye. Mm-hmm.